Have you ever stopped to wonder how the weather app on your phone instantly knows the forecast? Or how your social media feed just appears? Well, today, we're going to pull back the curtain on the invisible language that makes all of that possible. So let's start with that exact question. How does an app on your phone actually get information from some computer halfway across the world? It's a fundamental puzzle every developer has to solve, and the answer is a concept that is truly the backbone of the modern web, the API. Now, let's place this on our roadmap for today. We've got 4 key checkpoints to hit. First, we'll define what an API is, our digital bridge. Then, we'll look at REST, which you can think of as the rules of engagement. After that, we'll tackle JWT, our secure passport for data access. And finally, we'll talk about JSON API, a common language to keep everything consistent. All right, let's get into it. First up is the most foundational piece of this whole puzzle, the application programming interface, or as you'll always hear it, the API. The best way to think about an API is as a contract. It's not the database itself, and it's not the server. It's the set of rules that 2 pieces of software agree to follow. It's like one application saying to another, hey, if you ask me for information in this exact way, I promise I'll give you back data that looks like this. It's all about predictable communication. And this usually happens in what we call a client-server model. So think back to that weather app on your phone. Your app is the client. It needs data. It sends a request out to a remote server that has all the weather information. The API is the messenger, the go-between, that makes sure that entire conversation happens smoothly without any misunderstandings. Okay, so we've built our digital bridge. Now we need some traffic rules, right? We need to know how to cross it. This brings us to a huge checkpoint on your developer journey, understanding REST, which stands for Representational State Transfer. Now, the first thing to get about REST is that it's not a super strict formal protocol. It's more of an architectural style, a set of really smart guidelines. And it became the go-to way to build web APIs for a simple reason. It's flexible, it's lightweight, and most importantly, it's built to scale. And the absolute number one, most important principle of REST is this idea of statelessness. This is a game changer. It means the server has no memory. Every single request the client sends is treated like it's the very first time. As soon as the server sends back a response, it completely forgets about the client. This is the secret sauce that lets RESTful services scale up to handle millions of users, because any server can handle any request without needing any past context. So, how do we actually talk to the server? Well, we use a standard set of commands, or HTTP methods, that act like verbs. You use get when you want to read some data. You use post to create something new. You'd use put or patch to update something that's already there. And delete? Well, that one's pretty obvious. These simple actions are the building blocks for almost everything we do online. Okay, but wait a minute. This raises a really important question. If the server is stateless and forgets us every single time, how do we handle things like logging in or accessing private data? This is a major checkpoint, and the answer lies in a modern approach to something called authorization. And this table just nails the difference. See, the old way, on the left, was session-based. The server had to keep a list of every single logged-in user in its memory. You can probably guess that doesn't scale very well. The modern approach, on the right, uses something called a JSON Web Token, or JWT. And the key difference is where the information is stored. With JWTs, the user's identity is stored on the client side, inside a secure token. That frees up the server and unlocks massive scalability. So what is this JWT thing? Well, it's really just a long encoded string, but it's made of 3 parts, all separated by dots. You've got the header, which says how the token is secured. Then there's the payload, which carries the actual user info, like a user ID. And finally, you have the signature, which is a cryptographic proof that the token is legit and nobody has messed with it. It's basically a self-contained, tamper-proof digital passport. The whole flow is actually really elegant. First, you log in with your username and password, just once. The server checks them, and if they're good, it hands you back one of these signed JWTs. Your app then holds onto that token. And from then on, for every single request it makes, it just includes that token in the header. It's the perfect solution for a stateless world. You're proving who you are every time without the server needing to remember you. So let's recap. We have our bridge, we have the rules of engagement, and we have a secure passport. The very last piece of the puzzle is making sure everyone is speaking the same language. And this brings us to our final checkpoint, the JSON API specification. This quote just says it all, doesn't it? The whole point of JSON API is to stop what's called bike shedding. You know, those endless team arguments over tiny little details, like whether a queue should be camel case or snake underscore case. By providing a shared set of conventions, it lets everyone just get on with the important work, building great software.
It gives us a standard way to do common things. For example, let's say you need to get a blog article and the details of the person who wrote it. Instead of making one request for the article and then a second one for the author, JSON API lets you do it all in one go, just by adding $include equals author to the request. That's a huge win for efficiency.
And what you get back is just as predictable. The response structure is always consistent. The main thing you asked for, the article, will be in a data object. Its specific details, like the title and content, are in attributes. Any links to other things, like comments, are in relationships. And if you use that special include parameter, the author's information will be neatly tucked into the included section. It makes parsing the data on the client side an absolute breeze. So, we've made it through all 4 of our checkpoints. After all of that, what's the one big idea, the single most important thing to remember?
It's this right here. Modern web applications are all designed for scale, and the foundation for that scale is statelessness. By building on REST's stateless architecture and using tools like JWTs for client-side authorization, we can create systems that can grow to support millions of users without buckling under the pressure. This is the pattern that powers the global apps we use every day.
We've mapped out the state of things today, but that leaves us with one final thought to put on your own personal roadmap. As our software becomes even more distributed, with more and more pieces talking to each other, how do you think these API contracts will need to change and evolve? What comes next? This is Developer Roadmaps. Map your path, build your career.